So let's discuss inventory policy for Class A items. And the question we want to answer is, when does it make sense to spend more time and effort on finding better parameters than for just the B items? And again, it's a trade-off between this complexity and some other costs that we might be savings. And we want to say, is that savings worth the extra effort? Is it worth me spending the extra time, extra precision to find these optimal parameters and using more complex policies? Because I can put arbitrary values in for a min-max policy, but that might lead to a worse situation than a standard, say, SQ policy. So we want to decide, when do we want to add precision? And so if I look at the total cost equations, and the top one you'll notice is for that cost of stock out event, where B1 is the cost of, or the penalty cost of stocking out. D over Q is the number of cycles I'll have over the course of a year, and the probability of a stock out. The second one on the bottom is the cost of stocking out individual items. So CS is the cost of stocking out an individual item. The D over Q is the number of replenishment cycles I have over the course of a year. And remember, the sigma DL times GK, that unit normal loss function, is the expected number of units short each replenishment period. So for either of these types of policies, what's going to drive whether it's an A or not? Well, there's different segmentation policies, as we discussed in the second lesson of this whole course. However, the thing that really drives it is the revenue and the volume. And so that's either going to be driven by the C and the D, or the C times the D, the cost per item times the D, the annual demand. So that's really going to determine whether it's an A item or not. And so when we look at A items, if I'm looking at the C and the D, I've got two extreme cases. One, I have fast-moving but inexpensive product, where I have a large D, it's fast-moving, got a bunch of them I'm selling, and a small C, it's not a high value. My Q will probably be greater than 1, right, because I'm going to order a lot. I have a lot coming in. But the other case could be where I have a large C, it's a very, very high value item, but I don't sell that many of them, right? It might be a very high specialty kind of end item, but it's worth a lot of money, takes a lot of, brings in a lot of revenue, but I don't sell that many. And it could be that my order quantity goes to 1. I replace them as they come in. And so we have two cases for these class items. Now, of course, there's going to be things in the middle where you have, very fast moving and very expensive, but generally these are the two extreme cases, and we want to look at them each individually because they impact the type of distribution you're going to use. For these fast movers, right, with a large D, high demand, I'm probably going to use a normal or a log normal distribution, as we've been pretty much doing throughout the rest of this course. And it's good enough for B items, like I said, it's what we've been doing. And it's okay for A items if your expected demand over lead time, or your expected demand over lead time plus replenishment time, if you're doing a periodic review, is greater than or equal to 10. Just kind of a rule of thumb. And for slow movers, we're going to use a Poisson distribution, which we haven't talked about for a little while, but we introduced in the first week. And these are more complicated to handle, generally, not that much, but generally use these for A items if the expected demand over lead time, or lead time plus replenishment time, is less than 10. So let's get started. And we're going to first focus in on the fast movers, and then we'll focus in on the slow movers.